Full spectrum versus 16 pixels. Who does it better? Have you ever wondered how measurements carried out by a lab spectrometer differ from those carried out by our SenoCorder Solid? Today we will explore the answer to this question by comparing a conventional lab spectrometer with the Norix sensor. At first we are going to take a look at how a lab spectrometer records a spectrum. Then we will take a look at how the Norix sensor records a spectrum. We will carry on to compare the two, and in the end we will take a look at the question if 16 pixels are actually enough. Let's get started. In labs worldwide, most spectrometers used for the visible and near-infrared range are either based on silicon or InGaAs. Silicon-based spectrometers cover a wavelength range from 200 nanometers to 1100 nanometers, whereas InGaAs-based spectrometers cover a range from 800 nanometers to 1700 nanometers, in some cases up to 2500 nanometers. Both types of spectrometer provide very high-resolution spectral analysis. To come to such detailed insight, the dispersive elements in the lab spectrometers must be adjusted continuously. This results in a device being quite sensitive to vibrations and also quite large and bulky. On the bright side, however, measurements are very precise. The resolution can be set exactly as needed, and you get a spectrum with the desired level of detail. So if you were to take pasta to a lab asking for spectral measurements, the diagram you would receive would look something like this. The graph shows the spectrum of pasta in the wavelength range of 1100 nanometers to 1800 nanometers, with a resolution of 2 nanometers. This means that there is a measuring point every 2 nanometers, resulting in 350 measurement points. To create a better understanding of what this means, we have come up with a simple analogy. We will refer to that again later. So if you were to draw a birch tree in detail, you would draw roots, a trunk, bark, and leaves, as well as the leaf veins and detailed levels of texture. In this case, the graph showing the 350 points of measurement represents the detailed drawing. Let's take a look at the Norix technology. So the technology of our chip is based on thin film organic semiconductors and require no dispersive elements. It is a small, light, and robust sensor solution that can be implemented into everyday devices or used in the form of a handheld device. The chip inside has 16 wavelength channels. We call them pixels. Each pixel covers a certain wavelength from 450 nanometers to 1800 nanometers. The coverage of wavelength can be adjusted depending on the application. Using our SenoCorder Solid, you can measure the pasta on your own by placing the device on the sample and simply carrying out the measurements. Let's take a look at the diagram you would receive. There we go. So it shows a measurement of the same pasta as in the previous graph, but this time measured with the SenoCorder Solid. The wavelength range is 1100 nanometers to 1800 nanometers, and the resolution is 45 nanometers, which results in 16 measurement points. Coming back to the example of the birch tree, if this graph represents our drawing of the birch tree, it would be a sketch that shows little detail, except for the most important characteristics, such as the overall shape of the tree, with a simple representation of the trunk, branches, and leaves. Now that we have covered the technical background, it is time to determine whether 16 pixels are enough to get reliable results. So I have merged the diagrams for you. Comparing the two measurements, it is clearly shown that the lab spectrometer provides significantly more measuring points than the SenoCorder Solid. More specifically, 350 versus 16. The measured values of the SenoCorder Solid also differ slightly from those of the lab spectrometer. However, It is also obvious that the 16 measuring points represent the most important characteristics. That is to say that the SenoCorder Solid can qualitatively reproduce the spectrum of the lab spectrometer. So let's come back to our Berg tree analogy. Thinking of this information, we know it's a tree, it has a white bark, it has many small and serrated leaves. You would immediately know that this must be a Berg tree. You don't get information about the height of the tree, whether it's healthy or not, or what kind of insects are living in the bark. Questions that might be important for a biologist or an ecological scientist. But you get the information that it is a Berg tree, which is enough for everyday life. It is the same with the spectrum. A few measuring points covering the most important features are enough for most everyday applications. You might ask yourself questions like, is this pasta gluten-free or not? Is this textile cotton or polyester? Is this drug genuine or counterfeit? Answering these questions actually often requires less than 16 measuring points, depending on the spectrum of the material. So in most everyday applications, they are perfectly sufficient. If you have any further questions, make sure to contact us at inquiry@senorix.com and follow us on YouTube so you don't miss out on any new episodes. Have a good day.